Okay, so today we're going to go over lesson 1.2 or 8.1.2, and it's going to be over factoring. Before we can get started in that, though, we need to refresh on how to find the sum in the product for the generic rectangles. And we haven't really found the product working backwards yet in this class. So to go over this, remember, to find the sum, you just add up the like terms. So for A, if you were to write the sum, here I have product equals sum. Remember, when we multiply it out, the product equals the sum. So writing out the sum for A, you would get 6x squared because nothing combines with that 6x squared. Then the 2x and the 15x combine together, and you would get 17x from that. And then that 5 would just be there all alone, which is a plus 5. Okay. Now, to find that product, remember, that's the two things that multiply to get to that. And that's something we haven't done yet when we've been using this generic rectangles. So here's how we're going to go about doing this. Pick either a column or a row, doesn't matter which one. I'm going to pick I like to do columns, okay? So I'm going to look at here, I'm going to circle here for a second. I'm going to look at 6x squared and 2x. And what we're going to do is we're looking at that is we're going to look for the GCF, or what is the greatest common factor. In other words, what is the greatest number that multiplies to each of those? So I first like to look at 6 and 2. What can each of those be multiplied by? What's the biggest number that each multiply by 2? And that would be the 2. 2 multiplies to both of those. So I would write 2 down here. And then I see that the bottom one has an x squared and the top one has an x. So that means they both have at least one x. So then it's going to be 2x. Okay. Then you can go ask yourself, well, if you had 2x, what would you multiply 2x by to get 6x squared? So I'm just looking at the bottom box. Well, 2 times 3 is 6, so 2 times 3 is 6, so that would give me my number, and then x times x would get me x squared. So now I have that bottom left-hand box. Once you have that, then you just got to ask yourself, if you want to go through here, now 3x times what is 15x? Okay, so 3 times what is 15? You should be like, that's a positive 5, so I'm going to put a plus 5. Okay, and then x times what is just x? Well, that's just nothing. So 3x times 5 is 15x. Okay, so that the x just stays on that one that we already had. Now going up to the top left one, okay, you have a 2x down here. 2x times what equals a 2x? Well, you should be like, well, that's just a plus 1, just a positive 1, because we just need to multiply by 1. It's already there. So good. So then just check your last box here. So then you would have, how do you get 5? Does 1 times 5 that you have work? And yes, it does. So there we have our products. Now we just need to write it out. So I'm going to write it out here and make sure you put it in parentheses. So you have 3x plus 1 times, parentheses, 2x plus 5. So there is the product working backwards. All right. So let's look at another one. Let's look at number B here. Okay, so the same thing starts. I like to just look at the column. Okay, so looking up and down, so I look at the 5xy and that negative 2y. Okay, what is the greatest common multiple or greatest common factor that each of these have? So I see there's a 5 and a negative 2. Well, I know nothing multiplies to 5 and negative 2 that's the same besides 1. So, I mean, you can write a 1 there if you want, or you can just leave it so far. And then I see the bottom one has an x, the top one has no x's, so that's not a multiple, a greatest common factor. Okay, but I do see both of them have a y. So I'm going to put a y here because that's what each of them have. Okay, so that would be it. Now, if you had that 1 there, you would just have 1y, which is fine. You could write that, but you also don't need it. Now ask yourself, though, to find that just this bottom box, what times y gets you 5xy? Well, the only thing I'm missing is just the 5x, so it would just be 5x. Because 5x times y is 5xy. Now go about your rows and your columns here. So I'm going to go 5x times what? I'm going to go for that bottom right one. So 5x times what is 15x? Well, you should be like, well, 5 times 3 is 15. So I'm going to put a plus 3 because it's got to be a positive. Okay, and then I already have an x on that 5, so I don't need that x on the 3 because 5x times 3 will get me 15x. Now go up to the top left one, okay, the negative 2y. I already have a y down here, so y times what is negative 2y? Well, that would be a negative 2. So I'd write a minus 2. Now check your last box here in the top right. Negative 2 times 3, is that a negative 6? And yes, it is. So my product for that one is going to be 5x minus 2, and make sure you put in parentheses, times y plus 3. And then my sum, well, this is what we've been doing before, is just combining like terms. Well, you'll see none of these boxes combine together, so we're going to have 5xy plus 15x minus 2y minus 6. That would be our sum. Okay, I want you to pause the video, and I want you to try number C by yourself now. and resume when you're ready to check your answer. All right, coming back here now. So I'm going to look at the columns here, or the column again. Okay, I'm going to see that I have a negative 9x in the top and I have a 12x squared in the bottom. So first ask yourself, what multiplies to 12 and negative 9? That's the biggest number that multiplies both these. Well, 1 would work. Does 2 work? Well, 2 doesn't multiply to negative 9, but it works with 12, so that doesn't work. What about 3? 3 times 4 is 12. 3 times 3 is negative 9. Or 3 times 3 gives me 9, so that would work. Okay, then go through there. Well, 4 doesn't work, and then 6 wouldn't work, and so on and so forth. So our greatest one for that is 3. Now, they both have an x, so I'm going to put an x here because we need at least one x in each of those, and that's all that it has in the top one, so that's what we need. So now ask yourself, what do you have to multiply 3x by to get 12x squared? Well, 3 times 4 is 12, so I'm going to put the 4 here on the left-hand side, and then x times x would get me x squared. Now we have that bottom left-hand box, so now we can go for the corners. So 4x times what is 16x? So I'm looking at the bottom right-hand box. 4x times what is 16x? We should make 4 times 4 is 16, and it's positive. So I'm going to put a plus 4. X times, you don't need an x then to get 16x, so we just need that plus 4. Now looking at the top left-hand box, I need a negative 9. So I need a negative 9x, and we're going to be looking at the 3x times what is negative 9x? Well, 3 times a negative 3 would get me negative 9. And I already have the x with that 3 in the bottom, so I don't need it up top. Oops, I accidentally wrote one there. So we just have a negative 3 there. And I'm still on mine. So now write out your product and sum. So you would have 4x minus 3 times 3x plus 4. Okay, times 3x plus 4. And your sum, you just need to combine like terms. That was 12x squared. And then the negative 9x and the 16x combined together would be plus 7x. And then you have the minus 12 as well at the end. Okay, so now think about, you can flip your products here. You could have 3x plus 4 first and then 4x minus 3 second. Okay, but it would be the same thing. So this is kind of what we're going to be doing today. We're going to be working from the sum and we're working backwards to this product. All right, so we're going to be working backwards now. That's what factoring is going to be. So before we can move on though, okay, I want you to pause the video and just focus on this one up here, okay? And ask yourself, what do the two diagonals here that are circled have in common? Okay, pause it, and if you can't get it after 30 seconds, or go ahead and resume after about 30 seconds. Go. Okay, so now the two diagonals here, hopefully you found some common similarity between these, but here it is. So 6x squared times 5, so this is this one right here. 6x squared times 5 is 30x squared, okay? And if we also look at 2x times 15x, 2x times 15x here is also 30x squared. So if we multiply the diagonals, okay, they have the same answer. So the product of the diagonals is the same. So that's something unique about a generic rectangle here. If you multiply the diagonals, they are the same. So we already did A here. So let's check B on the one below, okay? So we have 5xy and a negative 6. So 5xy times a negative 6. Well, 5 times a negative 6 is a negative 30. And then there's just an xy on the 5x, so it's going to be negative 30xy, okay? Now the other one is negative 2 times 15x. Negative 2 times 15 is a negative 30. Y times x is also an xy. So it stays the same, okay? They're equal to each other. You can check it on C if you'd like. So you could pause it and you could check this. I'll tell you, it'll work. You should get negative 144x squared for each of those diagonals, all right? So that's something unique about these that we're going to use here, all right? That's something unique we're going to use. So that's something that we need to keep in mind when we're factoring here. All right, let me scroll down here. All right, so factoring. Factoring is the process of changing the sum to a product, and it's called factoring. So that's what it is. It's changing that sum to a product. Okay. Not every expression can be factored, meaning can be written in a generic rectangle. There's some that we just cannot get. Okay. So in the examples we've investigated from above, where is the x squared term always placed within the rectangle? hopefully you're like, all the x squareds are in the bottom left-hand corner, okay? That's where we will always want to put our x squareds. The x squareds are always going to be in that corner. I know sometimes we maybe don't build it that way, but that's where they're going to end up being for this stuff. So our x squareds are going to be in the bottom left-hand corner. Where is always the whole number or just the constant at the end always placed? So we're looking at just like the plus 5, the plus 14, the minus 12. Okay, hopefully like that's in the top right-hand corner. Okay, so that part's always in that top right-hand corner of our generic rectangle. So that's something that's going to help us out here. So keeping this in mind here to help us factor. So we're going to factor this one right here, the 2x squared plus 7x plus 6. Okay, so using what we just knew, let's put that 2x squared down in the bottom left-hand box. So make sure you guys are writing this stuff down so you can reference it later. So that you could call this like our A, okay? That 2x squared, I'm going to call this my A box down here in this corner. I'm going to put 2x squared in the bottom left-hand box. Then I'm going to put then that plus 6 right here, I'm going to call that my C, okay? That's going to go in this top right-hand box, okay? That's that constant and then. So we're just going to put a plus, you can put a plus sign, but it's the 6. Okay, that's going to go in there. We know that's there. Now, when we're factoring, just like we talked about, we need to find that diagonal here. This is why we wanted that pattern with the generic rectangle, because we're going to use our diamond problem here to help us out. Remember, the top part of our diamond problem is the product, okay, for it, which that's what our diagonal is. So 2x squared times the 6. So 2x squared times 6 is going to go up here. I'm going to write right here. So 2x squared times 6 is 12x squared. So that's going to go in our top part of our diamond when we're making these. So each time we factor, we're going to make a generic rectangle and a diamond. So that's why we're practicing the diamond problem. So we're going to put the two together. Okay? So that's why these two will go together. Now, the last thing you need is you need a sum here. Okay, we got to know what it sums up to be. And that's what these two boxes that we have blank in our generic rectangle are going to be. But we know that's what combined together to get us this 7x. But we don't know how the 7x needs to be split up. There's a lot of ways we could split up that 7x. So but we know that the two boxes here will add up to 7x, and that's what the sum is. So we're going to put 7x in the bottom of our diamond. Okay, and I guess if you want to call that a letter, you could call that B. Okay, so B is going to be our sum if you want to help reference that. Okay, so now going through this is just like we practiced with the diamond problems. Now, if two things multiply to x squared and you sum to x, you know each of these are just going to need an x because we need x times x to multiply to x squared. We need x's to add together to just be an x. Okay, now going through your generic rectangle, you can remember, not your generic rectangle, your diamond problem, you need to find the two numbers that add to 7 and multiply to 12 now. So going through, you can make your t-chart. 1 times 12, 2 times 6. So 1 times 12 is 12, but 1 plus 12 isn't 7. 2 times 6 is 12, but 2 plus 6 is not 7. So then try 3. Okay, so you're just going through this thing about this. 3 times 4. Well, that's 3 and 4. Those add to 7, and they multiply to 12. So I'm going to put a 3 in here, and I'm going to put a 4. So now that once we have that figured out, and we know that we got our diamond problem made, we're going to put that in here. We're going to have our 3x, and we're going to have our 4x. So that's how we knew how it broke apart. That's how it's going to break apart when we do this one. And now we can do what we have been doing since the very beginning when we were practicing. Okay? When we were practicing at the very beginning. So you're going to go through here, you're going to factor it. So looking here, I'm going to look at the top, I look at my column again. 2x squared and 3x, what do they both have in common? Well, 2 and 3, there's not a common multiple. But x squared and x both have an x, so I'm going to put an x down here. Then I ask myself, just to look at that bottom left-hand box, x times what is 2x squared? Well, x times 2 would get me my 2, and x times x would get me my x squared. And you can double check, x times 2x is 2x squared. Now, go to the bottom right-hand box. 2x times what is 4x? Well, 2x times, or 2 times 2 would give me my 4, so I'm going to put a plus 2. And x times, I don't need anything to get that x there, so it's just going to be a plus 2. Now that top left-hand box, x times what is 3x? Well, you should be like, oh, that's a plus 3. Okay. Now you've got it all factored out. So now we just need to write out the answer. Okay, so I'm going to write out, so 2x, so looking at this left-hand side first, I'm going to have 2x plus 3 times, what is my bottom part? Well, that is x plus 2, okay? X plus 2, and that would be my answer. That's what it factors out to. So that highlighted part is our part that it factors out to. 2x plus 3 times x plus 2. All right, so let's do one more here. Okay, just letting know this video is getting kind of long. All right, so let's look at this one. So 6x squared plus 17x plus 12. Okay, so remember, the x squared, the x squared part is going to go down in the bottom left-hand box. So I'm going to put 6x squared down here in the bottom. Please be writing this out and trying this one as I work through it. Okay, that plus 12 is going to go in the top right-hand part of our generic rectangle. So I'm going to put a 12. If you want to put the plus sign, you can. Now, we don't know how to break that 17x up between our two parts of our rectangle. So remember, that goes in our diamond problem, and that's going to be our sum here, okay? Because these two boxes add up to 17x. So that's going to go in the bottom part of our diamond. Now, remember, the product is that diagonal. So we need to figure out what is 6x squared times 12. That's going to go in the top part of this diamond. Well, 6 times 12 is 72, and then it's going to be x squared. Okay, I want you to pause the video now, and I want you to try and finish this diamond problem, and then fill in your generic rectangle and resume once you're done. All right, so resuming here. So 72x squared. So I see that it sums with an x, so I need to have both these with an x because it's got to multiply to that. And 72, going through here, find these. So 1 and 72. Well, that's not going to work. That adds nowhere close to 12. 2 and 36, still not there. 3 and 3 and 14. Okay. Sorry, not 3 and 14. 3 and 24. Okay, 3 and 24 is 48. I'm having a brain fart right now. Yeah, 72. Okay, that won't work either. So try 4. 4 would be 72. So you got to know this is where knowing your multiplication facts comes in really handy here. So 4 would be 72 divided by 4. That's going to be 1, and then 18. Okay, that one's closer, but we're still not to 17 yet because 4 plus 18 isn't 17. 5 isn't going to work, so try 6. Okay, 6 would be 12. All right, 6 would be 12 here. That doesn't work. All right, that's 18. And then try, you could try, see, 7. 7 won't work. 8. Try 8. 8 times what is 72? And that's 9. Boom, there it is. So 8 and 9. Okay, so that one took a little bit of thought. You had to work through a lot of numbers to figure that out. I hope maybe you found it quicker. Okay, but 8 and 9 are the ones. So we would put 8x, and then we would put 9x in our box. Okay, now finishing this out, I'm going to go a little faster here. 8x squared and 6x squared. So I'll circle them here. What do these have in common? Well, they both have in common here. They both have an x, so I'm going to put an x. And 6 and 8, what's the highest number that multiplies each of those? Well, 2 works for both, and then it'd be 3 and 4 for either of them. So, but it's just 2. Okay. So now 2x times what is 6x squared? Well, 2 times 3 gets me 6, and then I would need an x. So now working in the bottom right-hand box, 3x times what is 9x? Well, that would be just a plus 3. Okay. And then 8x, 2x times what is 8x? That would be a plus 4. Okay, so 2x times a positive 4 would give you 8x. Okay, then check your last box to get a 12. Does your plus 4 and plus 3 get you there? And yes, it does. So now write out your product. So you're going to have 3x plus 4 times 2x plus 3. Okay, and there is the answer for this problem. All right, so that is factoring in a general basis. So every time we factor, we're going to use a diamond and we're going to use a generic rectangle. All right, so please make sure that as you're practicing these, that you're doing this. I'm going to go ahead and put up Thursday's practice work as well for you guys, so you can go ahead and get a head start on that if you like. Otherwise, you'll just pick it up tomorrow for that.